Do you guys need a break from now till 12? Somebody say no. It's okay if you say yes. We can take 5-minute break maybe in the middle. 5 minutes. So maybe like 11:20 or something, let's say that. So I want you all to go to a site called, we are going through leaderboard section now, and I've linked here to Firebase. This is not a very hard link to remember, firebase.google.com. And you should be signed in the right. If you aren't, do sign in with your Google account. It doesn't really, well, pick your maybe private account if you have work one. Once you have logged in, are you logged in or not? I just want to see majority of people. Can you give me thumbs up? Yeah, many thumbs up. And then you press go to console. I have already many projects here. A couple pink games. That's for the preparation for this camp. I'm gonna add a new project. You should also have add project button there. Maybe it gives you some other welcoming display there, but you should be able to find add project. Now, you are gonna name your project. Am I sharing my screen?
Yes.
It just doesn't show a green like frame around it. So I'm gonna call it games because I have already pink games since before. You call it exactly what you want. Pink games is a good name. And continue. Second step, it should ask you about Google Analytics for your Firebase project. And I don't really care what you choose here. It doesn't hurt if we enable Google Analytics. It is recommended, so why not? It asks me configure Google Analytics. I'm not sure if it's gonna ask you if you are you're doing that for the first time. I'm gonna choose default account for Firebase. Does it ask you the same question? I don't think it does. Well, somebody says yes. Just choose default. And then we press create project and it should start showing us a little progress bar. I think we have Clara on the line also if you want to get help there, but I think it's better you stay here, like if there is some panic situation. Yeah, you can always get help on the comment session. Both Charlotte and Clara are looking at. So your project is ready. I click continue. So I have now a Firebase project. So under Firebase, there are different services that we can use. We are gonna go to Cloud Firestore here on the left in project overview. I have a button called Cloud Firestore. And right at the top, there is a button create database. You can click it. And Then it shows a window. I'm not gonna make any changes there at all. I just click next. The next step is, it says Cloud Firestore location, and it gives me a red exclamation mark. This is basically where geographically we are gonna place our database. And choose a value from this drop-down that has anything to do with Europe. So I have, for example, Europe 3, Europe West, because that feels closest to where we are. So it can affect, the location can affect the latency for communication with your database from where you are physically. The database is on Google's servers somewhere in the Western Europe. I have no idea. It's a secret probably. And then press enable.
Antonina?
Mm-hmm.
I'm sorry I missed what you did last. So we're in Develop, Cloud Firestore, and what did you do then?
Create database. At the top, there is like an orange box and it says create database.
Okay, thank you.
And then you just go with the defaults, and then you choose Europe as location.
Cool.
Like
Thank
Europe
you.
West. Now you have a database, and it's not an SQL database. This is something that is called document database. In a document database, we have different collections, and in every collection, we have documents. So that's basically the structure. And a document is a JSON object. What's JSON? That's JavaScript object notation. So you know how a JavaScript object looks like? Curly braces, some name, colon, Antonina would be a key value pair in my JSON object. So every document in a collection is a JSON object. So what we're gonna do here is we're gonna create a collection where we will save scores for our memory game. So press start collection, and collection ID should be memory. I use little m. I think standard is all small letters. So memory is my collection ID. I press next. And now actually, in order to create a collection, you need to have at least one document in it. So we're gonna create one dummy score object. Every document in a collection has an ID. We're not gonna care so much about those IDs. We're gonna let Google generate them for us. So for this dummy score object, click on the button Auto ID in the document ID field. And it's gonna give you some random letters and numbers. Now, we're gonna create our dummy score object. So what should a score object look like? So what did we say we wanted to use as the score for the memory game? How do we compare two players?
Time.
Time.
Yes. And apart from the time itself, We should also have, what do you think?
How many times the person clicked before they get everything right?
We could have that, but I just want to simplify this for now as much as we can. I'm thinking more like, say that you want to display your leaderboard. What else do you need except time?
Name of the players?
Exactly. Their names. So we're gonna have two fields, a name and time in milliseconds. So first field here, call it name. And we're creating just a dummy score object here. So pick your name as value. I'm gonna write Tonya. And we also choose type of this field. It should be string. This is the default type. String type. String is text, right? Then press add field. We want another field for our score object, and that's time. MS, I'm gonna call it. Time, big M, small s. I'm using the lower camel case notation here. So time MS, it means time milliseconds. Because if I just say time, well, it's not clear to, you know, for my peer developer in my project, what I mean. Type, what should it be? Let's look in this drop down. Well, we have a number. That's perfect. Number is completely fine enough for this. And what should the value be? Let's say that a slow Tonya has completed the game in, well, 2 minutes maybe. And 2 minutes is what? 120 seconds times 1,000. So 120 and then 000. I mean, this score object is kind of cheating, right? So we don't want to create some crazy score here that nobody can ever beat. And then you press save. Here. Now you actually can see what your database looks like. You have a collection called memory. Inside you have one document with this ID. And then when clicking on a document, it also shows the value. And if you want to go in and fiddle with this database later on, well, now we're talking about honor, right? So if you have some player who has beaten your score, you can go here and delete it, but would that be fair? Up to you. You can play once, you can change your score here. I can actually press this edit field button and I can say, oh, something else. I change the value and it will be updated right away. You can also add more documents manually here. Add document, you just fill. Yeah, it actually doesn't enforce you to you know, to create a document with the same fields as before. In the document database, it's not like we define, these are the columns of my table, like in SQL, if you have ever seen that. In SQL, you create a table, for example, users, every user must have a name, first name, last name, for example. And then every row in the database will have it. In the document database, you have a collection of documents and they can look different, but it's, well, handy for us, of course, to keep them the same. I mean, to keep the structure the same. So we're gonna have it like that, but it's not by enforcement, it's by us being good. Okay, so this is enough for me. I have a collection with one score object. If you want, add another score object, but it should have fields, name and time MS.
One question. So if we want to put another player, is it start collection or is it add field?
Add document.
Oh, okay, got it.
So the middle part. We only will have, like, okay, if we would have completed the whole camp, right? We'd have 3 games, Memory, Snake, and Minesweeper. So there will be 3 collections, Memory, Snake, and Minesweeper. Under every collection, there will be score objects, many of them, score documents, right? I am actually gonna go ahead and create another one, also auto ID. Field, it must have the name, type string, and I'm gonna have Charlotte here. I am pretending that she has played my game. Another field, time, MS, again, type number. She was a bit faster. I'm gonna do 110,000. Save. Now I have 2 documents here, and I can click any of them. They have the same fields, but different values for them. All right. So now I have a database, and now the next step is to connect to this database from our application. In order to do that, we go to our application. First thing we do, sorry, I'm gonna close these things. I'm gonna stop my dev server, Control-C. Why? I'm just gonna check so that I don't have any changes. I have some change. All right, that was the stopping the timer, right? I'm gonna go git add all. I skipped the pre-deploy and deploy, but I'm pushing the code to the repository at least. So I'm not updating my GitHub pages, but I have updated my Git repository in case you need that. So what I'm gonna do is I'm gonna install Firebase in my project. Do you remember which tool we used to install things? We did that npm. We did that during the setup, day 1. So we're gonna run a command called npm install Firebase. Now make sure you open the guide at the leaderboard page, because so 6 leaderboard, you have all the pages out here to the right, leaderboard, because I'm gonna be copying some code snippets from here. So what we are gonna do is we are gonna copy this code snippet here. And we're gonna paste it into our root index.js file. Root index.js file is the one not in memory, Minesweeper, or Snake, but in the root of our project. So this index.js file, it looks very short like that. Just React DOM render and some imports. Now underneath your imports, paste importing Firebase, and we're importing things like Firebase app. So we import star from that, so everything. We import also analytics, auth, and Firestore. And then in our index.js, we're gonna have a Firebase config object. And this config object is unique for each and one of us. It's something that we're gonna get from our Firebase database on the internet. I'm gonna show you where to get it. And after this config is created, we do Firebase initialize app. So we initialize Firebase with the config, then it's gonna know how to connect to your database. This is where the connection happens. I'm sorry. Okay. And then we also are gonna start the analytics function here. Don't really need that, but let's have it. And so far, that's it. So now we're gonna go and find our Firebase config object. Where were I before? Here. So we are in our Cloud Firestore. We are seeing the database. One thing we need to change in our database just before we go somewhere else, because we're already here, is we are gonna go to rules. And this is a specific Firebase syntax. So here you can define some security rules for your Firebase application. Maybe you don't want everybody to be able to write to the database. We're gonna try to keep it as simple as possible. So right now we're actually saying that nobody is allowed to read or write from the database. We say allow read and write if false. If false means never. And we're gonna change it to, there is exact value in the guide. Make sure that it's exactly correct like that. I just scroll down to reading from the Firebase. And there is a line here, allow read write if request.auth is not null. So I'm writing it also here. If request.auth is not just exclamation mark equals null. What we mean now is we need to be authenticated in Firebase in order to be able to write it. It's slightly better than just saying if true, at least. So we have changed the rules and we need to publish them. So press publish button. Another thing we should do here is go to the authentication tab on the left and click on sign in method. Maybe setup sign in method actually goes the same way, but click here at the top. We have the menu users, sign in method templates usage. Click on sign in method. And there are tons of different sign-in providers. So it's quite easy to integrate, for example, Facebook login into your application or some Google login, email password, phone. We're gonna go as simple as possible and we're gonna enable anonymous. So whenever somebody enters our application, they will sign in anonymously. So press the pen button, press enable and save. It should say anonymous enabled. So now we have configured these parts and now let's go find that Firebase config that we need. Press the button called Project Overview at the top. And scroll all the way up if you haven't. Project Overview should say that you have your project name, you have Spark plan, it's the free plan. It actually says down here at the left, Spark free, $0 per month. You're guys paying $0 per month for this. And of course, for the free plan, with the free plan comes some restrictions. You know, we have a restriction of 50,000 reads of the database per day. Now, that is actually not that hard to hit. If you have some kind of for loop that says, or while loop, while true, and you do a call to a database in that while loop, meaning that we're just calling the database. Like programmatically, it's very easy to write some code that executes very, very many times in a very short time. So it's not impossible to go up to 50,000 per day in just maybe like a minute. So we will be careful and not do anything silly so that we don't fill up our quota. But if we do, we can just wait till tomorrow, fix the code till the next day, or if we are in a big hurry, we create a new project in Firebase. So go to Project Overview, and here it says, get started by adding Firebase to your app while we're having a web app. So you can add it to iOS, Android, you can even have a Unity Firebase marriage. We are clicking the web button. And it opens this page here, and it says add Firebase to your app, register app. Choose a nickname for your app. I'm actually gonna use the same, games, or you can use Pink Games. I think you can have like one Firebase project and connect different apps to it. This is why you need to have nicknames for those apps in order to see the difference. We're just gonna have one app under our Firebase project, and this is our web project. And for me, I'm calling it games. I'm not gonna choose also set up Firebase hosting for this app. And I am clicking register app. Thing is that you can actually, so where does our website live now? It's public to the world, but where is it hosted?
On GitHub.
Mm-hmm. On GitHub pages actually, right? So there is, our project is on github.io. This is like when we publish our webpage, that's the URL we got. But yeah, it's a part of GitHub, right? So now, once I clicked some button previously, I come to this page and it gives me some code. Add these scripts to your index.html. We don't need to do this. You know why? Because we installed Firebase via NPM, and that's much more cool. We could have skipped that step, not install Firebase in NPM. Then we would need to add these scripts to our index.html page. But Webpack is gonna solve that for us when our code is packed for the web. So here's the Firebase config we're looking at. So copy this. It should be different for each and one of you. and go to your index.js where we just were, where it says const firebase config. And there we're pasting the content that we just copied. I think I copied too much. Just the object itself. It should look like this. Const firebase config equals object that you copied. And your values should be different from mine. You shouldn't try to write to my database, but to your own. Okay? Now we are basically connected. We can try to start our application and see that everything, that everything works. npm start. We're not reading the leaderboard from our database, but we're just checking so that Firebase has been installed correctly and we don't have any console errors from that. So our index.js is running, has been run already. And it's in index.js, so the entry point of the application. Before we render the React, all the React things, we have in index.js, React DOM render at the end, app document get element ready. That's where, when we say app here, it's our root component. This is where the whole story starts. React will render all of the tree, the component tree. Remember we were drawing it yesterday. But before React DOM render, we connect to Firebase. Firebase initialize, Firebase analytics. Wonder if we can see anything. Do you see in the head, I have some Google Tag Manager things? Those came from me initializing analytics. So we have some extra things going on in the head of our website. All right, next. We are going to try to read that leaderboard that we created from the database. We want that to appear somewhere in our application. And we're just gonna start simple. We're just gonna try to print it to the console. So say, for example, that we press the memory link. And maybe this is when our leaderboard should be printed to the console. Let's set that as a goal first. In order to do that, we need to write some code. So we are gonna create a helper file. So Firebase is gonna be used not only in the memory game, but maybe in the other games as well. So we are creating a helper file for that with some functions on the same level where our root index.js is. So I'm gonna add a new file and call it utils.js. And now, easiest is to just copy this code snippet that we have in the reading from the database section. So copy this code snippet and then we'll go through it. Into utils.js. So what we are doing is we import Firebase, we import the auth library and the Firestore library. And we have these libraries because we have installed them via NPM. Then we create a function. The export keyword is used for us to be able to import this function outside. So write export function fetch leaderboard. And as a parameter here, it takes game. Game is either memory snake or minesweeper, just a string. This is the collection ID of our collection. We have a memory collection. The ID is memory. So first thing we do is we get the auth object by writing firebase.auth. Then we get a database object by writing firebase.firestore. This code can be found on the documentation pages of how to work with Firestore. So this is nothing that you need to like know right off the bat. It's all documented and I have copied it from the documentation. I think links to the documentation are in the bio. And then now I have auth and I have DB. How do I fetch my leaderboard? I start with the auth object, authentication object. And on it, I call a method called sign in anonymously. It's possible because we enabled that anonymous authentication, remember? So first thing we do to fetch the leaderboard is we sign in. And in the database, remember, we have a rule that says read and write is allowed if auth is not null. And auth gets a value when we sign in for that rule, for the database rule. So first we sign in. And now comes an interesting syntax. It says then. Have you ever seen that before? Function then or method then? Have you ever heard about promises? JavaScript promises. It's quite a complex subject. But we are gonna just use the easy parts of it. So basically the way it works is auth.signin anonymously is a promise. And a promise is some code that is running in parallel to our main code. Basically, you can think about it like this. I am starting some process and it's gonna run in the background. So when you have started a process, you can call then function on it. And what this means is I am gonna wait for this process to finish. It's running in the background, and if I'm not calling then I'm doing something right after I have started the process, but I have not waited until it's finished. But when I call then on my sign in anonymously promise, it's a promise. I mean, I want this function that I sent to them, I want it to be executed after sign in anonymously is finished. And then I can chain lots of different things. And the beauty of it is if I do something afterwards here, outside of all my promise call chaining, I'm doing it right after I started sign in anonymously. So I can go ahead and do some important
this-
things. Mm-hmm.
Is this something called like asynchronous?
Exactly.
Yeah, okay.
So sign in anonymously is an asynchronous call. Asynchronous means in parallel to where we are. So think like you are a train running here, it's a thread running, and then you're saying, oh, do something here in parallel to this, to my thread. But when you are finished, do this. So normally this thing here is called a callback. So this is a callback function. Do it when you're finished. Very often when we send a function to a function, we call it a callback. It's a just very common term. So call this when you are finished. This is what we mean. And when this is finished, call this. So we are chaining then and then. And at the end, we are chaining a catch call. This will catch any errors that happen in any of these steps. So this is a promise chaining mechanism. So let's look at those functions that we have inside then. First we sign in, then we take our DB object and we write dot collection with a name. So we are saying that I want to fetch this collection. We're going to be sending memory as the value here. So this function fetch leaderboard takes a parameter game and it will be our memory. So we say DB collection memory. I want to fetch this collection and I want to order my items in the collection. Those 4 items, remember I created 2. I want to order them by time milliseconds. Ascending. Ascending means lowest value first and then it grows. So ascending from the bottom up. And there's also descending, which is the other option. Largest value first. And we're gonna have different ones. So in Snake, for example, it's the score that matters. How many food items we have eaten, and there will have descending. The highest score should be on top. Here we have the lowest time should be on top. So we have time ms ascending. Time ms is exactly the name of the field I have in my score object that I've created in Firestore. So first I say what collection I want to get, how it should be ordered, how the items in the collection should be ordered. And then I call the get method. And that takes time. I'm doing that asynchronously. I'm saying that this is my request. It's gonna go through the internet to my Western European Google data center. No idea where it is, but it takes time for that. And then my request will be processed and it will be returned to me. This is where it's gonna be returned to me. So this is why we need these promises. Then. And in the next call here, we receive an object. So this get call gives me at the end an object that we call query snapshot. I'm calling it like this because this is what the documentation of the get method says. It is a promise of a query snapshot. This can be a bit hard to process, but this is a lot of words, but that's what it says. The promise of a query snapshot. So it has promised me a query snapshot, and this is where I got it. And then I'm just gonna explain this part and I'm gonna take a break. So we have query snapshot. What do we do with it? So I want this fetch leaderboard function return me an array of those score objects. Remember we before had an array of card objects? Now I'm having an array of score objects. Every score object has a name and time MS. So I'm gonna now transform my query snapshot into a leaderboard array. First, I create a leaderboard array here. Let leaderboard equals empty array. And then I take query snapshot for each. So query snapshot is a special object and it's not already an array of objects. This is something that comes from the Firestore library. But it has a for each method. So all of this is documented and you can look it up. I can help you with the links if you have, but they are listed in the guide. So for each, and then we have a document object. When you say document.data, this is when you finally get that JavaScript object. Doc.data will return me JavaScript object. And what I do is I take my empty leaderboard array and I push this object into it for each document in the query snapshot that I receive here.
May I ask something? Yeah.
Yeah.
The doc on row 13. This is the first time you ever mention an object called doc. Okay.
Yeah, this is a variable. I can say document. You know, when we pass a function as a parameter, we come up with the name of the parameter ourselves. So it can be like that.
Yeah.
Also. Yes. So at the end, this function returns a promise with an array of objects as the result. So we can call fetch leaderboard memory dot then, and then we in the then function can do stuff with the leaderboard array. Now go take a break. Let's have a 5 minutes break until 11:30. I'm gonna set 6 minutes. Thank you, Charlotte, for pressing the record button. Okay. So this fetch leaderboard function that we have here, I'm gonna tell you that this returns a promise holding an array of our score objects. Game parameter is either memory, snake, or minesweeper collection ID. All right. So what does it mean now that it returns a promise? So it returns all of this chain of calls. And I'm going to show you how to use a promise. So let's go to our memory component. Index.js in the memory folder. And just as we did some testing here with the intervals at the beginning of the function, we are going to do some testing of the Firebase. So we are gonna try here to fetch the leaderboard and to just print it to the console. And we're gonna do it when we render memory. Actually, anytime we render memory. So every time you click, this code will be run. And it will be one time you fetch leaderboard, second, third, and so forth. So don't go crazy clicking maybe. But I think if we do it like manually, it's still no problem. You will need to click many times to reach 50,000. So remember we wrote this utils file with a function in order to use it in index.js in memory folder. We need to import it. So what we're gonna do is we're gonna import star, and star means everything. And then we give it a name also, like all the functions that we're importing from utils, they are gonna be accessed through a variable, which we will call utils. So we say import star as utils from, where is it? And now we need to find it. So we are in the memory folder. We go up one step and it helps us. Visual Studio helps us. We are now where app, home, navigation, and memory Minesweeper Snake folders are. So we are in the components folder. We need to go up one step again. .. and there we have components, images, index, and utils. I'm choosing utils. There. And now, let's go to the beginning of the memory component. So function memory, where it starts. We are going to write utils dot, and then in utils there was fetch leaderboard function that we saw before. And what does it want? What should we send here as parameter?
Is it the ID?
The collection, the collection ID, yeah, so we're sending memory within quotation marks. This is how we fetch the leaderboard. But, so this is a promise that when it has been executed, it will return the array with a score object. But in order for us to be able to do something with it, we need to wait for the promise to finish. And if we want to do something when the promise has finished, we call .then. And then we send a callback to this promise. And the callback, it actually takes a parameter that the previous promise returns. So when you chain promises, you have first one promise, it returns something. And then we have then. The callback to then takes the previous return statement as its parameter. And then it does something with that and maybe it returns something in turn. And then you can chain another then. It will take a parameter from the previous promise. And you can chain many, many promises like that. For example, I'm the first promise. I'm supposed to find my phone. I found my phone. It took me a long time. And then I give it to the next promise, to Charlotte here. So this is the result of the first promise, fetch leaderboard, for example. And I'm returning it. And then I am calling another promise in then. So I'm passing my return, value to the next promise. And this then here, it will take leaderboard as the parameter to the callback. What do we want to do with the leaderboard? Print it to the console. So I'm just going to go console.log leaderboard. And that's it. Save. Now, if this looks correctly, if we have done everything correctly, my memory doesn't svika mig. What's that? If my memory is working correctly and if I have shown everything correctly to you, then when I render my memory component, hello, here it is. I move this to the bottom, console. So I have rendered my memory component. And here I have a printout, array of 2. I can open it and see my leaderboard. And it is sorted by the time millisecond value. So Charlotte has the top score and I have the second score.
Sorry, can I have a question?
Mm-hmm.
So when I click on the cards, then it starts printing many, many times.
Yes.
This object. Is that how it's supposed to be right now?
Yes, yes.
No.
What happens when you click on a card? What code is executed?
It's printing in the console this.
Yeah, I know.
Yeah.
But I mean, the theory of what we're doing. We said that before, that every time we click a card, what happens to our component?
It's updated.
Yeah, so we update the state, right? And what happens when we update the state? Every time the state updates, the component re-renders. And when the component...
Is that calling for this information from database? Is that like drawing it from this 50,000 times?
Yes.
When I do that? Okay.
Yes. So we have placed this little test code in the top of our memory function. And this code is run every time the memory component is rendered. It is rendered every time you click a card. This is how it works right now. So it should fetch your database object every time you click, and it should print it to the console. So we have done the reading from the leaderboard section. And what I have built next on top of it is that we show leaderboard in a model. What a model is, it's basically a pop-up. So when the player wins the game, a pop-up should be shown and the leaderboard should be shown in that pop-up. And actually, now that we have this functionality, this was the hard part, right? To create a database, set everything up, to connect to it. And now this works. So the part where we actually show the leaderboard to the user, and you don't have to do it in a model, maybe you can just do it straight away on the page where the game is. It is now possible to do. So now we have a leaderboard object to play with, and we can display it however we want. So I'm considering that part as easier part than setting up database and all that. So I suggest that we pause and don't go to the model yet. We have our leaderboard in the console, so we have the data. Now we should learn how to write to the database also. So let's do that, because that's the complicated part of it all. I'm not saying creating a model and displaying all that is easy. I'm just saying that setting up a database is harder. So we're doing the harder bits first, right? So go to your utils file. And I'm gonna stop my dev server, just for now. We have a helper function there called fetch leaderboard. Let's write another helper function called save score. And again, I'm not gonna type it by hand, I'm gonna copy it from the guide. Scroll all the way down in the leaderboard document to exercise. And just above exercise, there is a snippet called save score. I'm copying this snippet into utils.js. Just underneath your fetch leaderboard, we'll have save score. And let us go through this code. What it does is, it takes two parameters, game and score. Game is, again, the collection ID, so memory in our case. Score is the score object, the JavaScript object with two values, timems and name. How do we save that score object in the database? Well, we go, we do first the same steps as we did before. We fetch our auth object from Firebase, and we fetch our database object from Firebase Firestore, just as before. Just as before, we do auth, sign in anonymously. After you have signed in, so wait for the sign in. When it's accomplished, then we're sending a callback. And we go again, we say db.collection, just as before, with the parameter game, which is memory in our case. And instead of doing order by and get, we call add. And what do we pass here? The score object. So this is going to be a new document in our collection. And then we catch errors. We don't return anything. I think. Oh, it does actually return something. But we don't really care about what it returns. We just want this to not cause any errors. We're not going to be using the return object. And I'm going to write a comment above this one. Returns a promise for saving the score. And when we have this save score promise, we can call .then on it. And for example, print to the console, the score has been saved. So when we actually print that, we know that the save score has executed, has been complete. So we save this helper function here. And now let's see where we can use this save score function in our memory component. I'm going back to index.js. And let me try find the line where I'm gonna try this. I have not done this call to save score that way before. I've done it through the model, but I'm gonna just freestyle a little bit here because I really want us to try calling this save score function when we have won the game. There are two ways I'm thinking I could do it. I think a nicer way is I'm gonna create, I'm not gonna go into one card click. I'm gonna create an effect. I'm gonna write use effect. It's gonna do something. And it's gonna do it depending on when, depending on our state. And what it's gonna do is if win, so if win is true, it is going to save utils dot save score, and then we are gonna write the name of our game. It took two parameters, remember, game and score object. So game is memory, and the score object we are gonna create here on the spot. So we are opening curly braces for the second parameter, and we are creating the score object, which will be name colon, and I'm just gonna save my name, Antonina, comma. The second parameter will be time ms, and that will be what value? Somewhere in the memory component, we have a state variable which contains the time that has passed since the start time. Do you remember what it's called? What do we display in the status bar? Time, colon.
Elapsed time.
Elapsed time. So up here is the elapsed time. So time ms is elapsed time. So this is our score object. And this code will be run only when we win. Another thing we can do here, so save score is a promise. We can, after this promise has been executed, write .then, and then pass a callback function. We want to print to the console that the score has been saved. So let's do that. Parenthesis, arrow, console.log and write score, save. So our effect, this is the effect. It depends on the changes of the win variable. Every time win changes, this function will run. And only when win is true, it will save the score. So if win changes to false, we won't enter this if statement. Now I'm gonna try it. I'm really hoping for it to work. I'm gonna open the console. So I enter my memory game and I have first printed the leaderboard. And now I'm gonna start playing. I'm gonna try to be as fast as possible to beat Charlotte's score of 110,000 milliseconds. Let's go. There, check this out. It says score saved. And interestingly enough, yeah, of course. Every time I clicked, I fetched from the leaderboard because I didn't remove that code. Well, silly me, but I think I can afford it. And then after I won, it seems like the component has been re-rendered a couple times. Well, it's probably because my state variables have been reset to some values or something. Can do an analysis of that later. But the most important part is that score saved has been printed. And also I see I have the leaderboard here with a new object. And the object has name Antonina and time milliseconds 20,006. That's quite good, I think. It has kind of shuffled the keys in these objects, but that's because, well, I don't know how exactly that works, but in an object, the order of keys is not important. In a list, the order of elements is important, but in an object, it's not important. We just want to have all the keys with all their values. You know what we can go and check now? We can go to Firebase. So I'm keeping this code here for you to write it down. I'm gonna go to my database, Cloud Firestore, and I'm gonna check so that I have an extra document, and I do. Here it is. It has received some random ID. That's what happens when I call add. So I do db collection memory and then .add, and then I send an object like this. And then it assigns a random ID to that document. So here it is. Here is my score object. Here are my other two score objects that I have created before.
Sorry, can I have a question?
Of course.
I'm sorry, I maybe missed that, but at what point did you assign your name to this object? Like, why is
Here.
it Antonina right now?
Here.
Oh, okay. But how, if we want to later on have a person to do it,
Yes.
will there be a way, or would that be anonymous?
The plan, or what we have in the guide, I hope that I can go through that. But you know what, guys? I think in the afternoon, after lunch, we should start building the snake game. So those of you who are like real snake fans, we want to satisfy you. So we will start building snake, and then we can jump back and continue working on the leaderboard functionality. And that will be adding a model, so a pop-up, where we display our leaderboard and where there also will be a field. So when you have won, you see the leaderboard and you see a text field where you can type your name, press OK, and that's when your score will be saved. So we have like the hard pieces implemented. Now what's left is the sprinkles. So now what we have left is fixing the front end part of it so that everything looks nice.
Antonina, you said something about if we don't want to fetch the leaderboard every time we click, what do we do?
Oh, yes. We should remove this code from the top of the memory component. Just, I'm gonna comment it out. So now I have a lot of comments in my code and my function memory is huge. Normally I wouldn't have so much comments and like, yeah, huge functions. I have a bad itch to refactor this file, but I think it might confuse you. So I'm gonna keep all these things there, but basically the structure of our component is import statement, function, some component name. Inside the function, we have use state calls. Then after them, we have use effect calls. And then we have the render. So basically what the return and then the whole markup. And then what we have done, we have also inserted some helper functions here and there, like on card clicked, on restart, generate game, flip card. All of those helper functions, they, I'm gonna write like that, function memory. And I'm gonna scroll down to the function we were before. So function memory starts here and there. And here we return something, some markup. And all the helper functions, they can actually be extracted to a separate file. That would keep our component like clean from all of that. We have everything in the same file right now. We have some functions, things here on top of memory. And then we have some on clicks, on restart, just here underneath the use effect. This is the two places where I normally insert helper functions. If I don't have 1 million of them, then I want to maybe extract them. All right, guys, let's take a lunch break and we continue at 1 and we will be building Snake. I'm gonna push my code to GitHub, don't worry. And I'm staying here if you have any questions for a bit, maybe 5-10 minutes. recording can be stopped.